Hello there. In this video, we're going to look at using progress bars with the Ciw Python package. And the main reason why somebody might want to do that is because they're impatient and want to see that some kind of progress is being made. There's other ways to do this than progress bars to get status updates. I mean, one of the very common things is having either a logging to a CLI, or another thing is to have logging files so that you can kind of take a quick snapshot of what's going on in the current state. So let's quickly go through this example here. First, we of course import Ciw, and then we look at defining a network model here. I've kept it simple. We've got an exponential random variable for the arrivals with a rate of 10 and a service time distribution with a rate of 20 that's also exponentially distributed. And then the number of servers is just 1 here. So we can run a little simulation. First, we want to set up our seed number so that we're saying run this in a reproducible way with this initial conditions for the random number generation. Initialize a simulation object, run the simulation for some amount of time, and then get the records. So let's run this. How to use progress bars. There we are. It takes a little bit because we're running for 100,000 units of simulation time, and there's a fair number of events that have to transpire in the system. So it takes a little while. It didn't take a really long time, but it would be nice to throw in some kind of way of getting a status update of the current state of the simulation. We can do that by using this progress bar argument that is available in the simulate until max customers function. And I believe it's also available in the other functions as well. Double check that. Yeah, also has progress bar. Or if I go simulation until max, until deadlock. Okay, offhand, not sure that deadlock supports progress bars. Oh, yeah, it can't because, okay, story for another time, but deadlock you can't because it wouldn't be well defined how much % progress you've got at any point. Okay, so progress bars, we've added that argument. What does it look like? It looks like something like that, right? And progress bars, especially for really long simulations, can give you a quick look at how far it's gone and allow you to do a quick mental calculation for how much longer you think it might take. So that's actually quite useful sometimes. However, this is just putting a progress bar on a single simulation. Maybe what we want to do is we want to put a progress bar on doing multiple trials rather than on a single simulation. And we can do the same, we can use the same tool that Ciw itself uses. It's a Python package called TQDM, and we'll import the submodule that has the same name. Is it a submodule? I have to double check the implementation of what this inside. What is this? Oh, it's a class. Okay. Decorate an iterable object returning an iterator, which acts exactly like the original iterable, but prints a dynamically updating progress bar every time a value is requested. Okay, great. And that's exactly what we're going to do here. So let's say that instead of doing just one simulation, we're going to do a bunch of trials. Let's set a number of trials. And in this case, let's just say it's 100 for the moment. We can increase that number if we like. I'm just going to put the constant literal up there. And then we're going to go for trial in, and then we can wrap TQDM around an iterable like range, where into range we might put something like number of trials, and just so that we're not doing exactly the same calculation, but rather a sequence of different simulations with a different random initial state, that will throw in trial into the Ciw seed function. So I'm also going to dial this down a bit. I don't know how long any of this will take. So this should instead produce a progress bar around your trials of running the simulation. Let's take a look. And there we go. So that was instead going over the multiple trials of running the simulation under different random seeds multiple times, which is a pretty common use case for simulation studies. So with that, I hope that that allows you to get some sanity for watching your simulations run as they run, and I will catch you in the next video. Have a good one.